So recall the data hazard again in this example. So here what you see is x1 minus x3 operation is performed, and if you look at this diagram, this value x1 minus x3 will only be updated in clock cycle number 5. So if x2 is used in the second instruction, you can clearly see that there is a data dependency and you need a forwarding circuitry to get the updated value. Okay? If you do not have the forwarding circuitry, you must install the clock cycle. Agreed? So while looking at the code, you do not need to analyze again and again, just memorize it. Whenever there is a data dependency in the next instruction, the data must be forwarded from the XMEM pipeline register, because the hazard is in the execution stage and we must pass the data from the XMEM pipeline register. Okay? When the data dependency in the following instruction after the immediate instruction, if the data dependency in this one, we need to forward the data from, so first of all for this one, we have to forward the data from the XMEM register. For this instruction, we need to forward the data from where? Mem write back. So by the time this instruction is in this phase, by that time this instruction, third instruction, is in the clock cycle number 4, which is the instruction decode phase. Where is the first instruction? The first instruction has placed its data already in the mem write back phase. Okay, so that is why we need to forward the data for this one, for x2. It should be forwarded from the mem write back phase. It should actually be going down. These lines are not aligned properly. It should go to RS1, which is this one, and it should go to here, RS2, which is x2. Okay? Any question? Yep.
I thought it goes backwards, like from the top register to the next line. Is it going backwards?
This one?
Yeah.
Yeah, so what it means is, I think you asked it previously also. So what is x1 minus x3? So x1, this instruction is performing x1 minus x3 in clock cycle number 3, right? And when this data will be updated in the clock cycle number 5, this instruction will write this updated value x1 minus x3 into x2 in clock cycle number 5, right? So when it is written in clock cycle number 5, but we are running the next instruction in the pipeline architecture. So by the time when this instruction fetches the value from the register file, that value of x2 may not be an updated one because it is not yet written. Okay? Because we are fetching the value in clock cycle number 3. However, the first instruction will be writing in clock cycle number 5. Let's say the second instruction is fetching the data at 9 a.m. and the first instruction will be writing the updated value at 11 a.m. for example. So you cannot get the value, the updated value at 9 a.m. of course. Okay? So that is why what we need to do is, as soon as this value is calculated here, because the value x1 minus x3 is calculated here at this point, right? And it is stored in this register, in this pipeline register. So why do we need to wait for this instruction to write the data into register file? We can fetch the data from here, right? And this is what we call forwarding. Okay, make sense? All right, so this was the data hazard. Next thing is a double data hazard. So for example, we have a condition like this. So first instruction is writing into x1. In the next instruction, we are using x1 as a source register. But this instruction is also updating the value into x1. Okay? So again, this source register is using the value, is supposed to be using the updated value of x1. So which means that there is a hazard in the execution stage, right? So here we will be taking the value from XMEM register, right? Forwarding from the XMEM register. What about this one? It is a hazard in the mem phase. If we would not be writing the value here into x1, then we can safely fetch the results from the mem stage. Agreed? because by that time, for example, look at this diagram again. So this instruction, suppose x2 is written here. So we can, for the next instruction, we can pass the data from the xmem register. Okay. But for example, if this instruction is also calculating and writing into x2 again, then the updated value, where is the updated value of x2 now? Is in the previous first instruction or in the second instruction? Tell me here, where is the updated value? Which instruction contains the updated value of x1? The second one. So which means that by the time this instruction reaches to, let's say, let me copy this one first. Do you see this? So here we have the dependency, because this one is writing into x1 and this one is using x1. So so by the time when this instruction reaches to this stage, so for example, we have when this instruction reaches here, sorry, this phase. Okay. And we had another instruction in this one, add, say it was also, what was that, x2, maybe x1, and let's say x3. Okay. So when for this one, this x1, where this instruction will be taking the data from, because it is performing an ALU operation in this stage. So where will it be taking the data from?
IDEX.
Huh?
IDEX.
So IDEX. So IDEX is this. This is IDEX. This is xmem. So currently the updated value of x1, which is performed by this instruction, is placed in this register, which is xmem, right? So we have to actually fetch the data from this stage, which is whatever the value. So this one will be fetched from here and it will go here, okay, for this instruction. When this moves forward further, let's say, let me go back here. And when these instructions move forward, this one comes to this stage, this one comes into this stage, and the third one is actually, this third one is actually in the last phase, which is this. So this is the write back phase. This is the mem phase, and this one is the execution phase. Now again, we have the dependency here. You see the x1 sitting in the IDX register, sitting in the IDX dot, let's say rs1, is equivalent to xmem. Let me write it like this. Is it equivalent to xmem dot rd, and it is also equivalent to mem write back rd. Okay. So where do we forward the data from? We forward the data from this register or this register? What do you think? Point it out with the xmem or mem write back. Which one? Huh? Mem write back or xmem? Xmem. Why? Because the xmem contains the updated value of x1. Okay? Xmem phase contains the updated value of x1. So that is why we need to forward the data from here and not from this one. Okay, so this is what we called the double data hazard. The hazard in both stages, execution stage as well as the mem stage. Okay, so what do we need to determine? How do we determine the conditions for double data hazard? So we know that there is a dependency here, x1 which is rs1 and x1 which is rd. So there is a data dependency between. So we should be forwarding the data from mem write back phase. But before deciding whether to move the data from the mem write back phase, we will also check if the same dependency exists in the xmem stage. If the same dependency exists, means that the rd is also same here, which is here also, then we will rather be forwarding the data from the xmem stage, not from the mem write back phase. So we need to update the conditions, forwarding conditions. Get it?